So I think we can start. Some people may join in later, but that's okay. Welcome everybody this afternoon to the third EDEN webinar on deep dive on requirements, analysis, specifications, and the EDEN Registry for long-term access and preservation services. These will be presented by Wesley Middelbos, who's also here, and I will also take a part of the presentation. And my name is Wilco Steinhoff, and I'm from KNAW Dans, and Wesley is from CERN. So let's start. First of all, yeah, it's a presentation outline. I'll start with the EOSC EDEN project in general, and then focus into the work package 2. Then Wesley will take over and will present on methodology and the timeline, information gathering, and current work and prioritization. Then again, I will take over and say something about the EDEN registry, the minimal viable product as we have created it. And I will discuss the components and say something about the knowledge base. And after that, you get the opportunity to for a Q&A to ask some questions. So first, the EOSC EDEN project in a nutshell. The full title is Enhancing Digital Preservation Strategies at European and National Level. It's a research and innovation action, so this mostly involves some development work as well, technical development work. Coordinator is CSC, Center for Science in Finland. These are the EDEN project objectives, and I think the keywords here are curation and preservation, but also consolidate the Fidelis TDR network of archives and repositories. So these are the consortium members. I think one is lacking, but I'm not sure because there should be 16. I counted 15. Going on to the work package 2. And work package 2 is about long-term access and preservation services and tools. It is split up into 3 different tasks, and the first task is defining system requirements and specifications, which is led by CERN. Task 2.2 is developing a registry and related selection guidance, automated curation and long-term preservation services. This is the task where mainly the implementation and development work takes place. Then we have task 2.3, the use case implementation, which is led by SURF. And I forgot to say, we have 10 institutions or 10 institutions that participate in the work package, and all 10 participants are participating in all 3 tasks. So here are the work package objectives: long-term access and preservation services and tools. We have the system specifications, which comprises of landscape analysis and requirements from user needs. There's the searchable EDEN registry. We want to publish OpenAPI or at least specifications for curation and preservation actions. Define standards and protocols for exchange and information packages. Here's an overview of the deliverables and the milestones. And as you can see, we had our first deliverable about specifications and architecture in September last year, month 9. And after that, task 2.2 and task 2.3 only kicked off. So we just had a milestone number 5, which is the minimal viable product release of the EDEN registry, which was due at the end of March, so last week. And upcoming milestone is milestone 6, which is the second iteration of the specifications and architecture document. From here on, I think that Wesley will take over about system requirements and specifications. So please, Wesley.
Yes. Welcome, everybody. Yeah, again, I'm Wesley. I'm working at CERN, and I'm also working on the EOSC EDEN project where I'm leading task 2.1. I'm going to talk about the methodology and timeline we used for the deliverable up until September. I'm also going to talk about how we structure this information gathering. After that, I will zoom in on one of the categories where we focused on during the deliverable, which is interoperability, and give you a little story on how we went from consideration aspects to attributes to specifications. And afterwards, I will talk a little bit about the current work done for the specifications and what we want to, how we want to continue. So if you go to the next slide, Wilco, please. So the timeline of the task 2.1 started at the beginning of the project, where we first started with just landscape analysis. So we tried to gather information about existing standard frameworks, practices, and we tried to like construct it in a certain way. And then somewhere around month 4 of the project, the first internal release of the core preservation processes became available. And at that point, we also started to think about service descriptions, which I will talk about later. Also, in month 7, at some point, the first iteration of discipline-specific requirements became available, which we partially also processed in the deliverable, which was due to in month 9 in September last year. If you can go to the next slide. Yeah. So a little bit about the methodology we took. It was a 6-step approach where we were already told in the last slide, we first started with the information gathering. The first thing, it's important to say that this step is not a linear way. It has been reiterative. The process cycled back repeatedly as new insight emerged. So first, we started with the information gathering, where we analyzed established standards and frameworks, including, for example, the OIS reference model, the FAIR principles, but also the EOSC interoperability framework. This gave us really a broad foundation on an initial set of possible requirements and also even already candidate services, which may be good to have. So after that, for example, after we got the core preservation processes and we got part of the discipline-specific requirements, we tried to map the right requirements gathered in the information gathering to those items to know, okay, which requirements we can map to each other so that we can know which parts can we support in which way. So after we had done this, we started a little bit to zoom in and get like more knowledge about what for design consideration, where we have to think about. So we started to look again to the sources, and we started to define considerations and aspects, which are essentially high-level challenges or opportunities, and aspects are related either solutions or more concrete challenges to which are taking part in this high-level problem. So based on these considerations and aspects, we also, if you come up with a solution for those, we want to make sure that you can like expose this. Users want to know, for example, if a certain problem is solved, yes or no. So this is why I actually identified attributes for it. And an attribute is just a descriptive property that characterizes a repository or a service. And these feed actually into the plant registry, where Wilco will talk about later. And it will allow researchers and communities to discover and evaluate a repository or service based on their needs to use. So in step 5, where we try to structure the services, we consolidated basically the identified services. Again, map them to the core preservation processes to check if they solve part of these processes. But also, for example, map them to later to the user journey maps, which came available after the deliverable. And at final step, we started to write high-level specifications in W3C format, which one of them is already released in the technical readiness level 4. Next slide, please. So now I'm gonna zoom in a little bit on how we structure the information gathering, because if we would have just started with collecting information about these categories, it would be like one big pile of like information without structure, which was going to be a problem. And so we try to look if there were already other initiatives, for example, within the EOSC EDEN, or within EOSC or EOSC EDEN, a structure which already partially did the same. So for interoperability, we found out that the EOSC interoperability framework already defined 4 layers of interoperability, which is technical interoperability, for example, which enables systems to execute, validate, and process digital objects without intervention of humans. But this indeed also includes open standards, machine actionable formats, and trusted persistent identifiers. It also had a layer, it's called semantic interoperability, which in EDEN context has to make sure that the meaning of preserved data is interpreted consistently across systems. Next slide, please. It's also organizational interoperability. Is there we try to align policies, responsibilities, and the workflows across organizations so that services and infrastructures can collaborate that more seamlessly. And also legal interoperability, which also became part of the information structure of rights and ethics, where I will talk shortly about. But it's ensuring that access rights, for example, restrictions, licenses associated with the data and services, for example, also copyright, are clearly expressed, that there is legally compatibility and machine readable, so that digital objects can also be reused and combined across like systems, borders, jurisdictions without with limiting legal issues. So now about data quality. For data quality, we reused what we call the RU-Fit framework. It's the reuse fitness framework we're created in, I think, one of our work packages. And where we especially zoomed in is on the 3 pillars, which is the contextual data quality, technical data quality, and the metadata quality. If you can go to the next slide. So the 3 pillars basically are addressing certain types of data quality. So for the contextual data quality, we trying to address the aspects of quality that should be verified by curators, or we talk about data which should be verified by curator on basis of best practices standards. For metadata quality, we will try to address the aspects of effective data discovery, access, interoperability, reuse, basically the established standard and practices such as the FAIR principles. And the technical data quality, we try to find solutions basically solutions to that can be automated, properties of a digital object that can be verified automatically, for example, by algorithmic methods, etc. So next slide. So for the rights and ethics, it's a little bit different because that evolved a little bit. So the rights and ethics information gathering got structured by aligning it a little bit with legal interoperability and with the expectation of fair care and trust. So we have a topic where we collected information about what's copyright and law, which is addressing legal and regulatory frameworks governing data including GDPR, international frameworks agreements, and data sovereignty, and also balancing open science and the protection of rights. We also had a part which was focusing on licensing and digital rights management, which is trying to address licenses that are clearly defined, which are compatible, and also support reuse of it, but also including standardization of like machine readable information of licenses, so that we can also assess them in for example, in an automatic way. So next slide, please. There are three more, such as policy considerations. It's basically focusing on clear, transparent, and standardized policies governing access, uses, and rights management, where policies should be actually consistently defined and support both human and machine readable interpretation of conditions. Contract preservation agreement is focusing on rights and responsibilities and conditions for preservation and access between stakeholders, ensuring long-term clarification and accountability. And ethics considerations, where we try to address ethical requirements such as protection of sensitive data and the need of ethical clearance. Next slide, please. So now I would really like to zoom in a little bit on how we came from design considerations to like specifications. And so what we did, we looked into sources such as the EOSC interoperability framework, and based on these sources, we defined a high-level problems and related problems, which we at the end partially based our finding identified services on. Excuses. So in the slide, as you can see in front of you, we are actually giving an example of one of the considerations we identified, which actually got extracted from the interoperability framework, which was later used for proposing the deposit guidance service. So this this consideration basically says the inconsistent of undefined service workflows across organizations hinder organizational interoperability. By creating fragmentation in how servers operate and interact. This is particularly evident in processes such as data deposit, onboarding, or metadata handling, which often vary between providers. The lack of clear terms, conditions, and acceptable use policies, combined with the insufficient guidance, participation rules result in misalignment of responsibilities and expectations across communities. So if you go to the next slide, one related problem or solution we found for this consideration is what we call aspect. Basically, is whether the system supports a harmonized community-aligned workflow for data publication and deposit. This includes indeed ensuring the data provides followed agreed protocols for metadata generation, format selection, validation, and submission. The standardization of deposit workflows fosters interoperability, simplifies reuse, and also ensures that consistent metadata quality is there across domains. So if we take these consideration and this aspect, if you go to the next slide, sorry. So yeah, the consideration aspect are for me basically the base for most of the next step flow for the attributes and for the services, and at the end also the specifications. And as we also identify attributes for these aspects, because we want to, people want to, for example, select a repository which says that they are aligned with community-aligned workflows. So for this, we try to define attributes, and this is, for example, this is an example of an aspect and a related attributes where a system should publish documentation explaining the legal or ethical restrictions applied to the data sets. An attribute for that, which we identified, was the metadata includes a justification for applied restrictions. So now we are at the service descriptions. The identification of the attributes and the service description basically went in parallel. But on the left-hand side, we basically have the consideration aspects and all the requirements we gathered through the landscape analysis. And by just looking at them in and discussing them, we found out that we can like combine them logically where they are in the processes. And for that, we derived basically service descriptions for them. Um, but at some point we had like more than 100 services, I think, in the famous, how we call the famous internal spreadsheet. Uh, for most of these services, we also registered existing tools and services which either fully already solved the service description, partially, or did not solve them at all. Um, so as we have to scope a little bit, because like 100 services might be a little bit ambitious, of course. So we had to scope a little bit and give priority to service which sounded feasible to do within the time frame we had, but all are also solving the identified challenges and actually aligning with, for example, the core preservation processes and the discipline-specific requirements. So what we did is based on metrics, for example, how many times a service was mentioned in the user journey maps, which became available after the deliverable, or how many core preservation processes we could map to them, but also how many requirements for the landscape analysis could we map to it, how many attributes to gather all this information. We put it in a sheet, and we did some initial filtering on there, and we ended up with a list of 29 services. Next slide, please. And for these, on the slide, you see a little example of how we filtered out all the how it would look like in the spreadsheet. But for these 29 servers, we will actually further elaborate in terms of either writing or writing specifications or referring to already existing implementations, and writing specifications for themselves, and in some cases, actual doing development also. So the current work, what has been done is at the moment we are writing actively writing 5 specifications for 5 services, which one is already released in the technical readiness level 4. You can either visit it by clicking on the TRL4 publishing GitHub or scanning the QR code, and please take a look. But we're also writing specification already for data quality checker service, the policy qualification service, one part of the license compatibility and guidance service, and the SOP to ARP factory. But we really would like to get your help a little bit, because we have 29 servers, but we of course want to deliver as much value as early on as possible. So we're asking your help. We have prepared a survey where we ask the community to, for example, prioritize 5 services. These services are mentioned in a very simple description in the survey itself. We would like to ask you to select 5 services and why they should be, and give the reason why they should be prioritized over all the others. And there is also the possibility to include some feedback on these 29 services. For example, oh, I think we are missing service ... And we will take a look at it, but because maybe we already identified it, but we maybe misqualified it as already solved, or maybe not feasible, for example. So please help us by filling in this survey. And I think I will hand it over back to Wilco, because he is now gonna present the EDEN registry.
Yeah, thank you, Wesley. So while everybody is busy filling out the survey at the moment, I will tell something about the EOSC EDEN registry. It is a registry of long-term preservation services and tools that are coming from repositories and long-term archives, with support for end users to select resources appropriate to their context by using filters and multiple facets. So when we started to look for building the registry itself, we needed to have some documents in place. So we have a Eden registry conceptual model, which is available from the link, but it is available from Zenodo. And we also have the Eden registry requirements and architecture. That might be a Google document at the moment still, and we have the technical specifications. So later on you can have a look if you're interested in. Then the registry itself. This is an overview, a high-level component overview of the minimal viable product, which is at more or less technology readiness level 3 or 4. So it's not very high, um, but it should do the job. And as you can see, we have more or less 3 GitHub repositories in which the code is stored for versioning. And coming from the bottom to the top, going from the bottom to the top, we have a harvester that collects repository attributes or properties from different sources. And then it is submitted to the harmonizer, which makes sure it fits into the model and there are no duplications. Then the harmonizer stores it in our backend, which is a triple store. And then it is being exported to an Elasticsearch instance, and the Elasticsearch instance is only being used for indexing, of course, searching, and creating facets on the web interface, on the user interface, which is not here. So it's not depicted in this overview, the user interface, the web interface, but it's on top of the Elasticsearch. So looking at the repository harvester, the harvester currently for the MVP harvests the Fidelis network repositories. So it visits their landing page and it looks for properties and attributes that it can find there, and it looks into different sources that I listed here. So it searches for JSON LD that might describe the repository. It looks for HTML meta tags, which could also describe repository affordances, RSS feeds, and sitemaps. It looks for signposting protocol, which can also provide information about the data sets that are in there, or even repository on the repository level, and Fairycat, which is also which is a protocol that is about repository interoperability affordances. So I will, if we have the time, then I can dive into it in more detail later on. And having visited the landing pages of the repository, it will also visit external registries. And at the moment, there are 2, but in future there might be more. So we'll query the re3 data API for that particular repository. Likewise for the fair sharing API. And then the data that is being collected will be sent to the harmonizer, as I just showed you. And its main function is deduplication and normalization of the data that is submitted there. Because if we collect our data from multiple sources, then we can have a problem. We have a problem. Mostly there are key value pairs, and that could be doubling DC terms title, for instance, or a DCAT name. And its value could be Pangea, for instance, or Pangea.de, or Pangea without an extra A or so misspell. And so the first problem could be solved by creating a mapping, like saying, okay, the DC title is the same as the DCAT name, and but multiple values are currently solved by three simple rules that determine their precedence. So the length of a string content could be looked at priority based on the length then. So if a string is longer, then it has precedence on the others. We could do prioritization of the resource, the source it comes from. For instance, we could say, okay, if it has been harvested by the landing page of the repository, then it has a higher priority, or it takes precedence of the data that comes in from R3 data, and so on. And another rule could be the frequencies count, or the number count of mentions of a property. So for instance, if Pangea.de is mentioned 4 times and the others only 1 time, then that one will take precedence. Okay, then the web interface, the user interface, it was created by the Dutch front-end framework, which was an existing framework that we updated and upgraded. It's a mono repository, as they call it. It's one repository, but it could host multiple projects. You just make sure, well, you start the right project. So it also serves the RDA knowledge base, for instance, and the compliance assessment toolkit, and now also the EDEN registry. We updated the documentation website, also accessible by the link. So here's the web interface of the EDEN registry, which I should stress is low technology readiness level. So the labels aren't that quite intuitive or what you expect it to be, but you can see where it's going to. At the left top, you can see the type, for instance. There are only two types at the moment, which is a catalog and a data service. So the catalog is a repository or an archive in DCAT, and the data service are services that are linked to, or discovered. They are linked to the catalogs. One or more catalog, of course. Furthermore, on the left column, there are a few facets available in which the user can filter or drill down to certain properties of the repositories. And in the main window on the right-hand side, you can see the repositories that match this filter. The detailed view is currently on the demo website not available because there's a small bug, but we have a detailed view of a repository that should be available there. But also a detailed view of services will be included, and a detailed view of profiles, which is actually a collection of attributes that Wesley just described. Mentioning attributes and profiles, these are the main entities in the EDEN knowledge base, which is work in progress. So in the knowledge base, we have attributes, and an attributes that captures the definition of a characteristic, an action, or a function of a repository archive of service. So an example is a harvesting protocol that's supported by a repository, or perhaps licenses that are supported by a repository. And then we have a profile, and a profile is a node that may be used to tag attributes to signify inclusion in a collection. So this is a long sentence for saying that a profile is more or less a collection of attributes that can be tagged then, or grouped, I should say. Then we have the repositories and services, and those may have profiles. Other entities could also have profiles, but so we have source profiles, for instance, the RDA Technical Repository Service Provider Working Group. They have defined profiles, so where they listed attributes that we can link to one group into one profile. Same goes for community profiles, for instance, the core trust seal, Registry data, or even the upcoming Fidelis network, the TDR network. Also, a single repository could have a profile, so that could expose attributes and saying, okay, I group those together, and this is what my repository stands for or publishes. And even a standard could have a profile, just like schema.org. And also a service can have a profile. For the EDEN repository, for the EDEN registry, the source profile and the community profiles are, and the repository profiles are important, should become important. So this is an overview, schematic overview of the relations between those entities that are available from the knowledge base. So you can see that a service that is offered by a repository that can be described in an attribute. So, for instance, it's the repository supports PMH, and the repository supports CSW. It offers file verification service, for instance. And the properties of the relation between an attribute and a profile allows a profile to define its own attribute label and URI or IRI, and is therefore able to define a benchmark. So, but this is advanced. This is not currently present yet. But we should be able to say, okay, for instance, we have a PMH endpoint and it supports version 2, for instance. So then this can be tested or benchmarked later on to say that you support or that you are well, supporting a certain profile, that you meet the criterion of a certain profile, I should say. So here we got the repository attributes, and well, it's just it's a long list. We have collected about 375. So here we see the sources where they come from, and well, and their numbers, but. So it's a lot of attributes. Here we have an example of profiles. So for instance, the core might be a profile, Registry data might be a profile, EDEN or the TTRAM even. So there are 39 profiles, and a profile is composed of a subset of attributes, and that can be benchmarked, as I already showed. So this is an example. It's a bit cryptic, but this is the RDA TSRP profile, and there are attributes linked to it. So these are the attributes, not all of them, but that are grouped into the TSRP profile. Okay, So a few use cases for the profiles. So repositories of services that have identified profiles can verify measured attribute values against that profile. So this has got to do with benchmarking. The repositories are services that wish to meet multiple benchmarks. For instance, we want to meet the Core Trust Seal, or we want to meet the Fidelis network. Um, the Fidelis network, yeah, and they should be able to compose a profile that supports all of these and their benchmarks. So can be used for assessment, certification. It compares measured values of a repository or a service to benchmark for a specific profile. And this is important also for the EDEN registry, for the web interface. So you can select or filter on repositories or services that satisfy the benchmark for a certain profile. There will also be a profile view, so then you can zoom in from a certain profile and see which repositories adhere or meet the requirements of that. And well, this is just an example to see how this benchmarking works. So for instance, you have a repository that says I have a metadata harvesting API as an attribute. And they have, of course, an endpoint URL then. And then it could be tested whether they adhere, for instance, to the OpenAir profile that says, okay, it has, you need to have a registry attribute, metadata harvesting API, and the benchmark is that it should be validated PMH version 2.0 protocol. Okay, I think we have a few more minutes. So this is the next step, because I can imagine that you say, okay, the knowledge base, that's nice with all the attributes and profiles in it, but how will this be maintained? It will become a maintenance hell, more or less. So this is where FairyCat kicks in. And FairyCat is about supporting discovery of a repository's interoperability affordances. So repositories can advertise the interoperability affordances that they provide, and they do so by linking a service to a URL. So for instance, if you go to a repository landing page, then often it's very hard to tell if and where the PMH endpoint is located, or even other REST interfaces or whatever. So the FairyCat protocol gives you an opportunity to public to yeah to public to publicize those attributes. Here I have an example of a link set. This is where all the properties are being published, and it gives you an anchor, which is the actual endpoint for machines. So you know, okay, I can go to that URL and then I find the service that is listed there. So for instance, it says service doc, which is a human documentation can be found there, but also more information in the service meta. And this will help us hopefully in getting the interoperability of the attributes of a repository clear to the registry. And therefore, we should have a look at the registry attribute editor, which can be used for well, automation and maintenance. It's well, it's a fairly complicated schema, I think, but the attribute editor should be able to read in a file, a link set file that I just showed, and create a form, a web form from it that can be edited by the repository manager. The attribute editor could also take information from the knowledge base that we have or from the EDEN registry and supplement missing stuff that might be or was available from external registries, so that the repository has submitted there. And then it could be edited, and in the end, the repository should be able to export this link set file and publish it on their repository. So I think that's it for me at the moment. Yeah, okay, this is a Dataverse implementation, example implementation for a Fairycat link set file. But that's it for me. Thank you. Thank you for your participation, and we hope to see you at our future webinars as well. And to stay up to date on the EOSC EDEN project and its sister project Fidelis, you can subscribe to the newsletter, which are there in the slides. Find us on different socials, Blue Sky, LinkedIn, YouTube. And a kind reminder is that you can find the recording, this recording, as well as the presented materials on the EOSC EDEN YouTube channel later. And of course, please don't forget to fill out our survey. It will be open for, not sure, Wesley knows, for I don't know, 2 weeks or so. And having said that, we wish you a lovely week and thank you for showing up.